Good morning, good afternoon, and good evening, everyone. So this is Yong Hong Kuo from the University of Hong Kong. So today it's our great honor to have Professor Jason Cao from University of Minnesota, and also he is the editor-in-chief of the Transportation Research Part B, and then to deliver our seminar series. So we also have Dr. Fanny Zhang here, and also Dr. Yijia Wang from the University of Hong Kong to join us. And before we start, I will briefly review our seminar series. So thanks to all the distinguished speakers, of course. So today we have Professor Jason Cao, and our previous speakers, all very distinguished scholars in the area to share their research and views. So many of them are very senior experienced scholars in the area and also editor-in-chiefs of journals. And then so we learn a lot from their research and then inspire a lot of interesting discussion. And today we'll have Professor Jason Cao, and then so in the next week, so we have Professor Pam from University of Birmingham, and then his talk will be on December 7th. And then so please stay tuned, and then so you are very welcome to join us. And without further ado, I would like to invite also Dr. Yijia Wang to introduce Professor Jason Cao. Thank you, Yijia.
Thank you, Dr. Kuo. I should say at the very beginning, it's really my great pleasure and honor to invite Professor Jason Cao to give this seminar. Since I was an undergraduate student, I know him well because he is really famous and a top scholar around the world, particularly in the research community of transportation and traffic engineering. So it's really my great pleasure. So please let me introduce Professor Jason Cao. Professor Jason Cao specializes in land use and transportation interactions, the effects of ICT on travel behavior and planning for quality of life. He has published more than 120 papers and edited 4 books. He is internationally well known for his research on residential self-selection in the relationships between the built environment and travel behavior. His recent work focuses on the applications of machine learning approaches in addressing the nonlinear relationships in land use and transportation research. He received his bachelor degree and master degree from the Tsinghua University and his PhD degree from the University of California, Davis. Okay, get back to Dr. Kuo.
Okay, thank you, Yijia. So without further ado, I would like to invite Professor Jason Cao to share his research. Thank you, Professor Cao. Yes, I will stop sharing.
So you can see my slides, right?
Yes.
Okay, very nice. Thank you very much, and Professor Kuo and also Dr. Wang for your nice invitation. And also, it's my great pleasure, to give a talk at the University of Hong Kong through this online venue. And I really miss visiting Hong Kong, and because of the COVID, and we are struggling. But also, we thank the Zoom, give us this opportunity, so that it means we can meet virtually. And my research is really about the kind of the machine learning approach in addressing the nonlinear relationship between the built environment travel behavior. And actually, because I think for many of you, the machine learning may not be new because it has been widely applied in the engineering field. But I think for many engineers, the focus is really on kind of the technical and methodological improvement in terms of the machine learning. And then my talk is really to try to change your mindset. So instead of thinking about the technological or maybe the methodological improvement, and then think about how to use this one as a tool to address the policy questions. So that means we're thinking about the connections among the variables instead of the advancement in the approach itself. Okay, so as we say, my research is really about the built environment travel behavior. So that means, I will just embed this talk in my field. So that's, we are really talking about the relationship between the built environment travel behavior. And then just a little bit of background about why we want to understand the relationship between the good environment travel behavior is really because of the auto dependence and also kind of the climate change associated with the transportation in the United States and maybe also in mainland China. And I think the Hong Kong did a great job in terms of controlling the use of automobile because of this dense environment and also very good transit system. But for many other parts of the world, actually, you can see the urban sprawl development, and then that motivate people to use automobiles, and then produce a lot of emissions, and then create a problem for climate change. So the goal of this line of research is really, how should we think about the development and the urban environment? So in that case, we can encourage the use of walking and biking, and also the transit, and also try to reduce the use of automobile. So this is really kind of the background. And then for the research community, when we try to understand the connection between the built environment and travel behavior, we often use, the kind of statistical models, try to analyze the transportation related data. And then the most commonly used approach is linear regression. Yeah, this is really kind of the simple linear regression, but actually, it's not that simple because, when we think about linear regression, we need to think about the 5 fundamental assumptions with the linear regression. The first one is, the relationship between y and x. So the dependent variable and independent variable, the relationship should be linear. Okay, if the relationship is not linear, so that's violate the basic assumption associated with the linear regression. Second one is, the variance should be constant. The third one is the distribution of the dependent variable should be normal. And then the fourth one, there are no apparent outliers, and the last one is, the observation should be independent. So that means, whenever we develop a linear regression model, we should check the 5 whether or not these 5 assumptions are valid. So now, for this talk, we are really focused on the first assumption. So it's really about the linear relationship. And then if you see this equation, so we have y equals to alpha plus beta n times x. So here beta is the slope. And then how to interpret the beta? The beta, across the entire range of x, associated with 1 unit increase in x, y will increase by beta units. So this is kind of the universal interpretation of the slope in the linear regression. But the issue is, is this valid? So, we want to see whether or not the linear assumption is okay, right? So how can we do that? We need to check the residual plot. So, this figure shows the residual plot between x and y, and the horizontal axis is the independent variable x, and the vertical is the studentized residue. And then if the relationship between x and y, they are linear, then, if you see those points should be randomly distributed along this zero line. So there's no pattern. But sometimes when we see the residual plot, we may see a plot like this. So apparently, from this one, we can see there are certain patterns. And so we see, when the x is small and very big, and then we see a lot of points is under the zero line, and then in the middle is above zero line. If we look at this residual plot, a reasonable assumption is, x and y, they are not linear, and probably is a quadratic relationship. So, if we just, think about compare these 2 plots, because we need to diagnose, this assumption, the implication is by default, the relationship between 2 variables should be nonlinear. So we should take this for granted. When we use linear regression, we assume they are just linear. Not necessarily. Actually the relationship should be nonlinear. So that's the reason, we need to check the residual plot to make sure, they are linear. And then here we talk about the nonlinear relationship. So what's the nonlinear effects? So here I will just kind of borrow the statements by Gauster, and in his paper of 2018, and he stated, actually the nonlinear effects suggest the size of impacts depends on the value of that variables. So here, if you see the figure 1, I show a few examples of the nonlinear relationship. If you look at the line of O and F, so this one is, thinking about, the Y is number of trips, and then the X is age. When the age increases, and then the number of trips will increase. So at the beginning, the slope is really big, But once you are reaching kind of the mid-age, and then the number of trips reach the peak, and then once you retire, and then the seniors, and then the number of trips will reduce. So that means you see a relationship like this. But also the nonlinear relationship can be like the OE and AC. So in this case, for these two segments, they have the similar slope. But once the x exceeds the x prime, and then we see a jump in the relationship. So this means we see the threshold effects. And also if you see the right lines, so OE and D. So in this case, we are going to see two thresholds. All of those examples just kind of the special cases of the nonlinear shape. And then the nonlinear shape can be even more complex. And then also in this field, we definitely see, there's some theoretical foundation for the relationship between the built environment and child behavior. One of the theoretical foundation is based on the time geography. So thinking about, we have 24 hours a day, and then, we need to conduct a lot of activities. We see so many constraints, right? So that means we cannot spend all of our time on traveling. And then this tells us, the linear relationship between distance to CBD and also the driving time, this linear relationship does not make sense. In the traditional understanding is, we see the distance to CBD and also the driving time, they have a linear relationship. So that means, once you live far away from the CBD, you are going to have a higher driving time. First, it makes sense. But the issue is when you are really far away from the CBD, actually, our daily activity is not centered on the CBD. We are thinking about our own centers. So that means we may see kind of the local center, right? So in this case, if you see the right hand of the figure, once the distance to CBD reach certain threshold, and then we see the effects, we see, it's become nonlinear, right? So this is based on the time geography. And also, maybe because of the dose response, thinking about, we have kind of a commercial area. So we have a commercial area, and this commercial area is going to serve the neighborhoods, around the commercial area. So when we see more business, and then, more people will visit this area, right? So that means we see a positive relationship between the number of establishments and also the number of people visiting this place. And then when the shopping area is getting bigger and bigger, once it exceeds certain level, this center is not just a local center. Actually, it becomes a regional center. So that means this center not only serving the people in this neighborhoods and also attracting people from other neighborhoods come into this area. So in this case, you see the number of people, you see a jump in terms of the number of people. Right. So this is another cases of the nonlinear shape. And also we see some other theories, think about the diminishing return, maybe central place theory, and all of this implies some kind of the nonlinear relationship. And then besides the theoretical foundation, and then, we study the nonlinear shape, for several reasons. One is, as a researcher, we always try to find the unbiased estimates of the association between variables, right? And then if the relationship between two variables is nonlinear, and then we use a linear regression, so that means we produce the best results, and then that's going to impede our understanding about the relationship. This is not good, right? And also think about the second is, thinking about the practical implication. How can we change people's travel behavior? Some people say, okay, if we change the building environment and people's behavior will change, and then others say, actually, it really depends on individuals' demographic attributes. For example, if you are the high-income people, you are low-income people, and then we see the variation in travel behavior. And then the question is, which one is stronger? Is that because of your demographic attributes, or that's really because of the urban form you live in, right? So if, for example, the building environment has very small impacts on people's behavior. So that means, using the building environment intervention to change people's behavior, may not be that effective. And then, for the, if we try to model this nonlinear relationship, and then we have a better understanding about the importance of the building environment in affecting people's behavior. And then the third one is, even, the building environment intervention are powerful. So that means they can change people's travel behavior. But the building environment actually including many components, right? So that's really about the population density, or this land use mix, or this is street connectivity, or maybe because of the transit, right? So all of those factors will influence travel behavior. And then a natural question is, which element of the building environment will have stronger influence on people's behavior? Because, always, the budget for planning intervention is limited, right? So that means we really need to prioritize certain dimensions of the building environment. So that means, we can reduce the auto dependence effectively, right? So in this case, we try to understand this issue. And also the next one is, we want to have compact development, and but we really want to see the threshold associated with that compact development. On the one side, on the one hand is, if we have dense development, and then dense development will reduce driving and also reduce the travel-related carbon emissions. But on the other hand, the density means, we are going to see high development costs, and also some research shows, higher density development is associated with lower life satisfaction, right? So that means the density, for some dimension is good, but for our other dimensions, actually, it's not that good, right? So that means, we really need to find a balance, okay? So, how dense is enough to reduce the carbon emission, right? So this is the question we want to ask, and then we want to see the threshold associated with that density. And then how can we find the threshold of that density? We rely on the development guidelines. One of the example is, created by the Center for the Transit Development. They create this development guideline, for different types of the TOD. And then they have a different specification. For example, if you see the last row of this development guideline, that one shows the minimum floor-area ratio. So this is really kind of the concepts of density. And if this TOD is in the regional center, the recommended minimum floor area ratio is 5.0. And then if this is the urban center, it's 2.5, right? So, this gave the planner some sense, if we want to develop a TOD in certain area, and then how dense it should be. But the problem is, how did we get this 2.5 and 5.0? Most likely is based on the kind of the experience of the planners, or maybe their imagination, right? And it's not really based on this rigorous scientific research, right? So, we really, as a planner, we really want to have this evidence-based intervention. So that means, we want to use the empirical study and trying to figure out the threshold associated with compact development. So those are the kind of the four reasons, we want to study the nonlinear shift. But even we talk about the nonlinear shift, actually, this is not it's not new, right? Because we have many studies have used many approaches trying to understand the nonlinear shift between variables. Here I show you just kind of a few examples, and so the first example is this one is really trying to understand the proximity to metro transit, and then also the housing value. And particularly in Hong Kong, if you leave, the right of the metro station, you need to pay a premium associated with that, right? So, this research is really trying to understand how the proximity to the real transit influence the property value. And then what they did is, they divide the area of station area into four components, four buffers. The first buffer is within 400 meters of the station area. And the second one is 400 to 800 meters. A third one is 800 to a mile. And then the last one is beyond a mile. So in this case, the researcher create these three dummy variables, include them in the linear regression of the property value. And then if you see the last, the parameters in the red box, and then you can see, if the property is within 400 meters, actually you see the increase in property value compared to the property outside of 1 mile buffer. And then, the increase is at the scale of 0.7, at about 0.7. But once, the property is about 400 to 800 meters, and then you can see the parameter is about 0.38. And then when it is between 800 to 1600 meters, and then the coefficient is 0.24. right? So that means, yeah, we see, in general, when a property is further away from the metro station, we see the premium is decreasing, but also decreasing in the nonlinear way. Because it decreased from 0.7 to 0.38 and then 0.38 to 0.24. So it's not linear. So this is one way, to address the nonlinear issues between the two variables. And then here is another example, using the quadratic function. So in this case, the dependent variable is the VKT, vehicle kilometer traveled. And then one of the X is the residential density. And then they assume y and x, they have this quadratic relationship. So that means, they include a residential density and also the square term of that density. And if you look at this figure and then the blue line, so this indicates the connection between VKT and the residential density. In general, we see when the residential density increases and then the VKT decreases, and then once they reach about 4 point something and reach the kind of the minimum, and then start to increase after that. So this is using the quadratic function to illustrate this nonlinear relationship. And then the third approach is called the log linear or Poisson family function. And in this study, the researcher, they use the data from San Francisco, Los Angeles, and Chicago. And what they did is, they have the VMT, the vehicle miles traveled. First, they take a log transformation and then create a new variable. And they're using this new variable as y, and then the residential density as the x. And then they try to use the linear regression, and then they find out actually they have this log linear relationship. So we can still see as the density increases and then the VKT decrease very fast at the beginning, and then you see the elbow points and then decrease slowly. So that's another example of the nonlinear relationship. And also we have some researchers trying to use the general additive mixed model. And so this is a really kind of a semi-parametric model, and then trying to understand the nonlinear relationship. In this study, Professor Ding and colleagues, they try to understand the relationship between the residential density and also the e-bike ownership in Zhongshan City. And then if you see this figure, when the residential density increase, a little bit, we don't see much change in terms of the e-bike ownership probability. But once it increases to a certain level, we see a kind of a linear decrease. And then once reaching the residential density reach about 25, and then you can see, the relationship become flat. So this is another example of the nonlinear relationship. Maybe there are some other examples, using the traditional approach to address nonlinear issue. But the problem with those approach, there are two concerns. One is, even though those studies, have figured out the nonlinear relationship, but actually, they do have a strong assumption. So for example, if they use the log linear, so they assume the relationship between x and y is log linear, right? So it has to be log linear. And then whether or not, if the relationship is not log linear, and then they may find out actually the relationship is not significant. So in that case, this restrictive assumption produced a false false inference. And then the second one is, maybe, for a linear regression, they have quite a few independent variables. And for the first independent variable, x1, and then maybe the relationship is quadratic, and x2 is log linear, and then x3 is linear, x4 could be even more complex, right? So if we have this irregular nonlinearity exists, among all the independent variables, if we just use this kind of preset, pre-specified nonlinear relationship, actually, we may come up with a false conclusion. So that's really, we should look for something else, try to have a better understanding about the connections between the variables. And then the machine learning become available, right? So this is one approach, we can try to tackle with the nonlinear relationship. And the machine learning, includes many approaches. For example, could be the tree-based, could be the neural network, could be supporting vector machine, and so on and so forth. And here, I'm going to use the tree-based approach. For example, could be the random forest or gradient boosting decision trees, XGBoost. So in that case, we use this tree-based approach to illustrate, how can we use machine learning to illustrate the nonlinear connections between variables. And first, I want to briefly talk about the rationale for the decision tree. How the decision tree, make prediction. And then what decision tree did is, we have a sample. So, and then we are going to divide the sample into many subsamples. So for example, we have two independent variables, x1 and x2. And then first, we can use x1 to make a division. So if x1 is bigger than m, and then we divide, this, using the m as a threshold, we can divide the sample into two subsamples, either on the right-hand side or on the left-hand side. And then the second step is, we can based on the x2, right? So if x2 is bigger than t, then we come out with the subsample b. And then if it is smaller than smaller than t, and then it's subsample a. And also we can do the subsamples c and d. And then we can keep, dividing this sample space into many small regions. And then what the decision tree did is, once we have all of those small regions, and then for each small region, and then we use all the observations within that region, the average as the predicted value. And then we have observed value, and then the observed value minus expected value. So this is the error, or we can say it's loss. And the goal of the decision tree is really trying to reach the minimum loss. So this is really similar to the ordinary squares. Ordinary square is, we use a line to approximate. But here, decision tree, we just divide them into many different small regions, and then using those regions, to make the prediction. And then, this is a very brief introduction. And if you want to know more about decision tree and also the gradient boosting, here I provide, two YouTube video. They are really, this is, if we look at the formula, it's for sophisticated. But if you watch those videos, and then it's very intuitive, and then it's not a lot of jargons, so it's more easy for you to understand this method. Okay, so if you are interested in the details, and then you can try to watch those videos. And then for this gradient boosting, compared to the traditional approach, there are some benefits. The first one is, they can try to figure out this irregular nonlinearity. And then the second one is, they can provide a prediction that is more precise compared to the traditional approach. And third one is, they can handle the missing data and outliers better, right? So for the traditional models, if we have the missing data, we may do the stepwise least deletion, right? So in that case, we are wasting the precious data points. But when we use the gradient boosting decision tree or machine learning, we don't have to remove those missing data. And also, for this gradient boosting decision tree, they have some packages. They can show the relative importance of independent variables. So in that case, can help us to answer the research question. And also, they can produce the partial dependence plots. So we can see the connections between the dependent variable, independent variable in a nonlinear way. So those are kind of the benefits associated with the machine learning or GBDT in particular. But also the machine learning, you see some limitations. If we have the linear regression, we want to have the p-value. So in that case, we can see if we can do the hypothesis testing to make sure the observed relationship is real. But unfortunately, the machine learning, they cannot do this. And also some scholars criticize the machine learning approach because it's going to overfit the data. And, even though we can, using some approach to reduce the extent of the overfitting, but more or less, the overfitting is still there. And then the third one is, the machine learning, you see the higher learning cost and also computation cost compared to the traditional linear regression. Because, that's one step further compared to the traditional models. So that means, we need to spend some time to learn the tools. And also if the data set is really big, it's going to take a longer time, to fit the model. Next, I'm going to show you one case study, just show you, how we apply this gradient boosting decision trees, and then to understand the connections between the building environment and the travel behavior. So this is a study, between me and also Professor Ding from Beihang University and Paternes from Norway. And in this study, the motivation is, we really try to understand the importance of centers in determining people's behavior. We know the urban form have evolved from the monocentric to polycentric. And then we see the city centers, region centers, and also in the neighborhoods, we see the local centers. And then one question is, what's the influences of different type of centers on people's driving behavior? And to answer this question, the planners often, just because we know respondent's home address, and then we can measure the distance from resident home, to respondent's home, to city center, and also from home to the regional center, from home to local center. We have three independent variables. We put all the three independent variables in the equation of driving distance, and then we want to see which one is significant, right? So in that case, it can tell us the importance of those factors, those centers in people's driving distance. But, when we see most studies, they often find out actually the distance to city center, this variable is significant. And then for the other two centers, they are not significant. So if they are not significant, the implication is actually the regional center and the local center, they have no influence on people's behavior. But I don't think this makes sense, right? Because they exist. They have the reason to exist, right? So in that case, we really try to understand the role of centers in people's activity location decision. Okay, so what affects people's activity location decision? And then Professor Paternes, they developed two rationales. One is the best facility, and the other one is proximity. For example, this Thursday is a Thanksgiving Day in the United States. And then because, after a year, I really appreciate my wife's contribution to the family. I feel, okay, I should give her a gift, right? So, okay, maybe, if, she loves the luxury bag. So if I want to buy the Louis Vuitton or maybe the Prada, and then where should I go? Apparently, I need to go to the city center, because that's the place, those luxury bags, located, right? So this is really because this is a specialty goods, and then people will visit the special area, for the best facility. But eventually, because, the inflation is so high, and then, our salary is stagnant, I just feel, okay, I'm not that rich, right? So I cannot afford a luxury bag. Maybe if I want to show my appreciation, maybe I can just do some, say dumplings. Right? So if I do the dumplings, I need the meat and also the vegetable. So should I go to the city center to buy the meat and vegetable? No, not at all, right? Because I can find the pork and also the vegetables in around my neighborhoods, right? So this is really for the non-specialty goods. The proximity become a very important factor. Based on this example, you can see, both the city center and then the local center can play a role in my decision making. Then both of them should have influence on my driving distance, right? But why, we see the city center is significant, but the other two centers not significant, is maybe because of the methodological issue. So that's the reason, we want to use this data, trying to answer the following two research questions. The first one is, we have this different type of center, how important they are. Second one is, we want to see the threshold of those building environment variables. In terms of the empirical context, we use data from Oslo. So Oslo is the capital city of Norway, and the so this one shows the kind of the density, employment density of Oslo. And if you see those dark area, in general, the Oslo is predominantly is a monocentric city, but still in this monocentric city, we can still see some regional centers and also the local centers. And then for the data, we use the data, using a self-administered survey, and then we have the weekly driving distance at the dependent variable, and we have the key building environment variables, including the distance to the city center, second order center, and local center, and also we have the population density, job density, and some demographic attributes. We use the GBM package in R to estimate a GBDT model. Next, I'm going to show you the result. So in this model, we have two sets of independent variables. One is demographic attributes, and the second one is the building environment attributes. And then if you see the last column of this table, this shows the relative importance of those variables to predicting the driving distance. So this is kind of the relative importance. If we add all of those, all the relative importance together, it's 100%. So this is just kind of, for this particular variable compared to all the contribution as a whole. And if you look at the result, and then we can see the most important variable is distance to city center. So this single variable explains about 18% of the predicted power, right? And this result makes sense because during the weekdays, people will commute. And then in Norway, because most of the jobs are located in the urban area close to city center, so that means you are far away from the city center, and then you are going to have a longer commuting distance. And in fact, this result is based on the weekly distance. But if we just look at the weekday, actually the relative importance, this one reach about 30%. So that means we can see, the distance to city center really play an important role in affecting people's driving distance. But with that said, we can also see the distance to local center and second order center. They also have important influence. Of each of them account for about 10% of the predicted power. And then if we add this two relative importance together, this is about 20%, right? So it's even more important than the distance to city center. And the third finding is we look at the age. The age is the second most important variable. So this variable, is a proxy for the life cycle. And, if you are kind of the young couple with kids, and then, for example, your weekend life is really centered on the children's activities. But if you're the empty nester, so that means you can just, arrange your activity by yourself, right? So that means we see a large difference between the people with different ages. And then this affects even more salient, on the weekend. Actually, during the weekend, the relative importance of age reached about 24%. In a brief summary, the top three importance variable in this model is the distance to the city center, and also the age is second most important, and population density is the third most important. And if we add the relative importance of all demographic variables together, it's about 57%. So that means, the contribution of the building variables is more than the contribution of demographics. Next, I want to show you the partial dependence plots. So in this case, we can see, the horizontal axis is the distance to city center, and then the vertical is predicted VMT. And then when the distance to the city center is smaller than 12 kilometers, we see there is a positive relationship between X and Y, right? And this makes sense, right? So when you live farther away from the city center, you see a higher driving distance. But once you reach about 12 kilometers, and then you can see there is a jump in their relationship. And then a flight, between 12 to 20 kilometers from the residence to city center, and then we see another small jump. Okay, so this is a clear indication of a threshold relationship. And next, we are going to see, the center bottom figure. This one shows the distance to the second order center. And then here we also see a threshold relationship. when the distance is smaller than 8 kilometers from the city center, we see a relatively flat relationship. But once it exceeds 8 kilometers, we see a jump in the driving distance. And the third one is the distance to the local center. And when the distance is smaller than 4 kilometers from the city center, we see a smaller increase. But when it exceeds the 4 kilometers, we see a jump in the VMT. So here, all three figures, we show a clear evidence of the threshold connections. So in summary, we see the city center, they play the most important role in predicting driving distance. But the second order center and local center, they are also very important. If we add their relative importance together, actually they are more important than the city center. And then the second finding is, we do see the nonlinear effects, particularly the threshold relationship. When, for example, for the distance city center, if the distance exceeds 12 kilometers, and then we can see the weekly driving distance, additional 30 kilometers of weekly driving distance. So that means we see a large increase in the driving. And then when we see all those results, what's the implication for the policy making? The Oslo is more progressive city. And their plan is in the next 25 years, they are going to achieve this zero increase in carbon emission. But we know the population will increase, right? So when the population increase and where those additional people live, that affects the carbon emissions. Based on this research, we can tell the urban planners in Oslo, if you want to do the infill development or maybe compact development, so in that case, you should, try to build more residential units within 12 kilometers of city center, 8 kilometers of second order center, and 4 kilometers of local center. So in that case, we can reduce the auto related carbon emissions. So this is kind of a case study, how we come up with this theoretical question, and then how we use machine learning, trying to tackle with this question. And then some students say, my research is not really about building environmental behavior. I don't think this is really useful. But not really, because here I'm just give you some, kind of the logic, how should we frame research question, and then how can we use the machine learning as a tool to answer that research question. And then here I can give you some additional examples, some additional examples using the machine learning. For example, this research, trying to understand, the neighborhood urban morphology on the air pollution. Right? So this is not about travel behavior, this is more on the environmental side, trying to understand the connection between the building environment and also the air pollutants. And then the next study is, trying to understand the connection between population density and the waist-hip ratio. Waist-hip ratio is really about the obesity, right? So that means, this approach can be used in the public health area. And then the next example is, trying to understand people's commuting, building environment happiness. So that means we try to understand how people travel and also the environment they live affects people's well-being, right? So you can see, it's really, the machine learning is really just a tool for us to address a very important policy question, right? So that means, don't just think about the machine learning as, a technical issue. We try to, develop some tools and make it more accurate in terms of the prediction. Actually, the machine learning can be a useful tool to answer very important policy questions. But when we decide, should we use the machine learning or the traditional models, to tackle the question, there are a few issues we need to consider. So first one is, don't just throw all the data into the model, okay, into the software package and let the model run. You should have a theoretical reason, why, the relationship between X and Y should be nonlinear. Okay, so that means, your research should be theory driven instead of data driven, right? So in that case, you have, it's guided by the research. So in that case, you have, otherwise your research may appear kind of ad hoc. And then the second issue you need to consider is, whether or not we can use a traditional approach to easily model this nonlinear connection. Yeah, because the machine learning is still kind of advanced compared to the traditional models. Many people, they will understand, say, the linear regression or the discrete choice modeling, but they may not understand the machine learning. So if we achieve this task through the traditional models, maybe, we don't really need the machine learning. And the third one is, yes, there is a theoretical reason, and also the traditional models, is not going to address the question. And then now we have the results. But that's results, we hope you can make some unique contribution to the field. So you can, using this new approach, we can improve our understanding, right? So because some people say, yeah, the nonlinear relationship is not really a new question. We have used many approaches to address this question. What you did is really just put new ones in the old bottles. And for this particular area, actually, the machine learning did provide some new understanding, challenge the conventional wisdom. For example, in this estimation, we found out, in this case study, we found out the building environment have a larger contribution to driving distance than the demographics. So this is different from the traditional understanding. The traditional studies have found out, the demographic are more important than the building environment. So in this way, we can increase the efficacy of the planners using the land use planning tools to change the building environment. The second one is, we do show the relative importance of different type of centers. Particularly, we highlight the importance of the second order center and then the local center. That's also improvement in terms of understanding. And then also the next one is, this study, we do find out the threshold, right? So for the building variables, they have a threshold. Within that threshold, we see different influence. So that inform the planning intervention. So with that said, I'm going to conclude my presentation. And then the overall idea is, don't treat machine learning as kind of focus on the methodological components of that approach. Use it as a tool to answer very important theoretical questions. Thank you.
Thank you, Professor Cao. Yes, I think if anyone have any questions, then you may put it in the Q&A box, and we would highly appreciate it if you can also let us know your name and also affiliation. Thank you very much. Professor Cao, would you also like to share with us on TRD, Transportation Research Part D, or you wish to do it afterwards?
I have no preference. If no question now, I can share some information about the TRD.
Sure. And then participants, please, you may also leave your questions in the Q&A box. Before that, I wish to introduce Professor Fuqi to you. He is here because I didn't realize it. Yeah. Thank you, Professor
Okay,
Chung.
thank you. I'm just trying to learn. Hi, Professor Chang.
Professor Song, nice to see you.
Nice to see you.
So I just realized Professor Chung joined us. Yeah, thank you.
Thank you. Yeah, it's not really my area, but it's really the important topic and interesting to learn. That's why I quietly participate.
Okay, thank you.
Yeah, I learned a lot.
Thank you. Okay, so so please, Professor Cao, so we would highly appreciate if you can share with us, especially PhD students or young faculty members, about publishing in transportation research Part D. Yeah, thank you very much. And participants, please, you may leave your questions in the Q&A box. Thank you.
Okay, now I'm going to share my screen again, and just give me a second. So. Okay, now you see my slides on the TR-D, right?
Yes, thank you.
Okay, so I'm one of the editor-in-chief for this journal, Transportation Research Part D and the Transport and Environment. And then the other editor-in-chief is Professor Bob Noland from Rutgers. and he's going to step down by the end of this year. And then Professor Ying Ge from Tsinghua University, and he will replace Professor Bob Noland as the new editor-in-chief. And so first, I want to give you some understanding about scope of this journal. So the TR-D is about the environment. So, this journal is really trying to understand the interaction between the transportation environment. It can range from local impacts to the global impacts. And even we say the building environment, the environment, but actually the environment is more broadly defined. You can see the studies associated with the travel behavior, because the travel behavior have the environment implications, and also the air quality, the ecosystem, road ecology, global climate, public health, land use, economic development, and quality of life. So this is really kind of the broadly defined the environment. And also we want to know focus on the transportation policies that has environmental impacts. When we implement, for example, congestion pricing, and then how that will influence the air pollution and the carbon emissions, and also empirical research that informs environment-related policies, right? So, this is kind of in general about the scope of this journal. And then in 2018, this journal introduced a new section is called DART. So it's disasters and resilience. For this section, we focus on the issues associated with the severe weather. For example, the tornadoes and then the hurricane, and also something related to the climate, the resilience, and evacuation, disaster, and heat and storm water, and so on and so forth. So this is kind of this section. And then in terms of the specific area, we have some primary areas. So we see a lot of summations along this dimension. For example, we see the alternative fuel vehicles, and particularly for the electric vehicles. We see a lot of papers, different issues associated with electric vehicles. And then the second large area is about the carbon emissions and air pollutants, right? So this is related to the environment. And then the third one is the travel behavior, and particularly, the driving related to travel behavior. And the fourth large area is marine transportation. Apparently, this is also the environment orientation. The maritime transportation is also kind of a very large area, but we only focus on a small area, area of this particular field. And we also see some niche area. We just talk about the disasters and resilience. So, and after 4 years, we publish about 25 to 30 papers a year, on this particular field. And also we see some research related to noise. Yeah, because the environment, this is the environmental impacts. When we see the highways, you are close to highway, you see a lot of noise, and also the airplanes, you see the noise, how that the noise can be mitigated, and how that noise influences people's the health. That's kind of the issue. And also we have some research on the pavement. The pavement is also focused on the environmental impacts of the pavement, and the aviation, and the road ecology, particularly the collision between vehicles and animals, maybe the airplanes and birds. Those issues belong to the field of road ecology. And also we see some research regarding the emerging technology, for example, the shared mobility and the autonomous vehicle, but also it's really focused on the adoption of those emerging technologies and also the environmental impacts. And we also have some research focused on the well-being, about the people's satisfaction, travel-related satisfaction. And finally, we focus on the equity, the social equity, because this is about the environmental justice. So this is just kind of, a brief understanding about the studies we publish. But also clearly, we have something we don't really publish. If this study is pure modeling, so I have an OR model, and then I use some numerical example. And so in this case, we consider, this is a Mansard paper, right? So that means it's better for you to submit the paper to, a Mansard-oriented journal, right? So for example, the TR-B or maybe the OR journals instead of the TR-D. We think TR-D is more of a policy journal. But with that said, we do not discriminate against the Mansard paper. But in that case, the Mansard is really a tool to address policy question. We hope the paper should emphasize the policy instead of emphasize the methodological improvement. And the second area, we don't publish is about the automotive engineering. For example, if you have some fuel additive and then trying to see how that fuel will improve the emission, or maybe how can we make the adjustment the engine, so in that case we can reduce the emission, then that's something we don't publish. In general, we want to focus on a group of vehicles instead of a single vehicle. And the third area we don't publish is about the kind of the off-road vehicles. And also the industrial operation, those, we are considered the traffic. And the next area is about traffic safety. If this research is about crashes, in general, we don't take those papers. But, always, some exceptions, right? So if you think, your work may be related, and then you can send an email to the editor-in-chief, and then with your abstract, okay, and just ask us whether this one is within the scope. We can, tell you, at least based on abstract, we can give you some sense whether or not this will fall within the scope of this journal. Now I'm going to introduce some statistics with this journal. And for many of the scholars, they pay attention to the impact factor. So the impact factor for this journal in 2021 is a little bit over 7. And then the set score and is about 10.5. Based on the set score, actually, this journal is among the Q1, the first 25% of these 3 fields: civil engineering, environmental science, and social science. So I would say this is a kind of well-regarded journal in the field. And also for the authors, you are interested in the processing time, and on average, this journal, the first round, you can get your first round report in about 2 months. And yes, because this can be not a normal distribution. You may see some of the long red hand tail. So that means we do have some papers could be half a year or maybe even longer. But that's really just a few cases. But for vast majority is about 2 months or fewer. And then for the final decision is about 17 weeks. So this depends on the comments, and also depends on the responsiveness of the authors. Right. So, but in general, I feel this is pretty good compared to other journals in the fields of transportation. And also, the TRDD is a major journal in the fields of the transport research. In last year, we see about 2,200 submissions, and our acceptance rate is about 16%. So this is a very selective journal. And also we see, standard reject is about 18%. But of course, we desk reject a lot of papers. When you have 100 papers, 66 were desk rejected, right? And then among those 66 out of scope, that's about 30%. For example, if you submit a paper about the traffic crashes, so it will be desk rejected because it's out of scope. And also we see about 13% of this 2,200 papers, 13% of the 2,200, that's some level of plagiarism. The scholars from all over the world, and also from the young scholars, and also the senior scholars, we do see the plagiarism all over the papers. And the third one is the poor English. The paper is poorly written, and then we often ask the author to have some editorial service to polish their paper, and then they can resubmit. And then the next big category is the lack of novelty. Just the paper and nothing new to the literature. So we just reject the paper. And since we are talking about the plagiarism, and also this can be a very important issue, and then I just want to briefly introduce the plagiarism. So what is a plagiarism? So here I just want to borrow the words by my advisor and Dr. Patricia Mokhtarian. And she said, actually, there are 2 types of plagiarism. The first one is you use others' words or idea without giving them appropriate credit. use others' information and then just don't cite them. So this is the first type of plagiarism. The second one is actually you cite the source for the idea, but when you use the source exact words without using the quotation mark. So this is the second type of the plagiarism. So when you use the exact words, even you cite, but you don't quote, that's still considered plagiarism. Okay, but this is something, many authors, they just have this issue, right? So when they cite their paper, I did cite, but because you use others' exact words, but without quotation mark, and then that's still considered plagiarism. Because for the Western scholars, when they see the sentence without quotation mark, they assume that's your words, but actually that's not your words, that's others' words. And also, how can we judge the plagiarism? Some authors just question us, my similarity rate is only 9%. And then this is okay, for our system, but why you still consider this is a plagiarism? I want to tell you is, plagiarism is not just about the similarity index. We look at the patterns of your sentences. In some cases, even, just one sentence, you use the source exact words and without quotation mark, that considered plagiarism. But in that case, we will regard it as a minor violation. What we do is we send the paper back to you, ask you to correct it, right? So you just paraphrase that statement and cite it, then that's okay. But for some papers, we see the overlaps one after the other. So this is considered a major violation of this policy. So in that case, what we did is we will mark you in the system. So that it means we know you have violated this policy once. And then if you violate this policy for the second time, we will boycott your future submissions. So that's the reason, I want to single out this one issue. So for the young scholars, and then please pay attention to the plagiarism. Okay, don't make this mistake. So this is just kind of a very brief introduction to this journal. And then if you have any questions about the journal and also about my machine learning presentation, and then you are welcome to ask.
Yes, thank you very much, Professor Cao. I think, in addition to the inspiring research you just shared with us, the experience you handle TRD is very valuable to young scholars like us and also PhD students. So may I now invite Dr. Yijia Wang to host the Q&A sections, because I see, participants have raised some questions. Yeah, thank you, Yijia.
Okay. Thank you, Dr. Kuo. Thank you, Professor Jason Cao. Thank you for our nice presentation. We find some questions from the chat box. The first one is from Cao Yunzhi. He said that thanks for Professor Cao for the great sharing about the applications of machine learning. I'm wondering, when using machine learning approaches in operations management and transportation error in a paper, what is a good contribution? Could you please give some examples? Because if we just use machine learning, it may be challenged by the reviewers.
Okay, first, I'm not in the field of operational management and transportation area, so that means I cannot provide you a concrete answer to this question. But, here I would say, in terms of machine learning, there are two ways to apply it. So first one is, we use machine learning as a methodology improvement. So that means our approach is really, we try to make some methodological improvement, right? So the contribution of this paper will be the methodology. And then if you just use ordinary machine learning, and then the reviewer will say, this kind of research has been seen, I don't think it does not add anything new to the literature. They will just reject the paper. And then for my presentation, what you can see is, this is really in my field. We use machine learning as a tool, just like a linear regression. We don't pay much attention to, okay, so should we use the random forest, and should we use the GBDT, or should we use the some other machine learning approach? I don't care. What I care is about that question. So what's at stake? In practice, what's the connection between these two variables? And then if we have a solid answer for this question, how can it improve the planning and practice, right? So the focus of this paper is about the policy, right? So that means, yes, I use machine learning, I can answer this question. I use a linear regression, I can answer this question. But when I use machine learning, it provides additional insight in that relationship. It can help us have a better understanding. So that's the reason, because I'm talking to the students in the industrial engineering, and this is faculty of engineering, right? So I think you have this mindset. My paper has to be in methodology. I have to make the improvement in methodology, but not necessarily. I used to be a civil engineer, but now I'm a planner. So that means I pay more attention to the question itself. Okay, so that means when you try to apply a machine learning, that conceptual, the theoretical foundation for your research is more important than the method itself. Right? So my interest is not to show, if I use the gradient boosting, the predicted error is this big. When I use random forest, the prediction error is that big. So that means the GBD is better. No, this is not our interest. Our interest is to show the connection between these two variables are different if we use machine learning compared to if we use the traditional approach. So this is kind of just, try to change your mindset, how we consider machine learning as a tool.
Yes, I totally agree with Professor Cao. I think that machine learning is really popular, so many scholars hope to use it, but they maybe forget or ignore why we use it or the benefits to use it. So I think it is really a good question. The next question is that from Sam from Hong Kong U. Thanks, Professor Cao. Would you share with us, did you encounter any computational challenge, say requires strong computing power or long computational time in your machine learning research in transportation and land use? Thank you.
This is a very good question. And, the machine learning, it can deal with the large data, the big data, and also can deal with kind of the small data. And in the field of transportation, we often have a the sample size is around a few hundred to a few thousand. Yeah, sometimes we do see longer computation time, for example, 15 minutes or 20 minutes, right? But it's not that long compared to other fields, right? So, maybe, my answer does not provide a good reference for your particular field. And so the second point I want to mention is, now I'm kind of the senior. So that means, my skill is really trying to have this oversight about this field. And then I want to see this result, how this result will inform the field. I don't really deal with the machine learning myself. So I don't do model myself. So actually it's really my student, my doctoral students, and also my collaborators, they do the computation. So that means, I may not be able to give you some insight on that part.
Okay, thank you, Professor Cao. The third question is that I think most of the scholars are really concerned about it. What is the popular research interest of TRD recently?
For this question is the popular interest. Okay. So for example, one of them is about the shared mobility. The shared mobility, and we did a special issue, we see more than 100 submissions. Yeah, so we do see, a strong interest in the shared mobility, and also the electric vehicles. Electric vehicles, that's another very popular area. And, the air pollution and carbon emission, that's kind of the traditional topic. has been the pillar of this journal. And but in terms of the search of the summation, is really, you know, the shared mobility and the electric vehicles. So those are the two most popular areas.
Okay, thank you, Professor Cao. The last question from Dr. Rhyme, India Institute of Management, Ahmedabad, India. He said, can you share a book on well-being? Another question is that how generalized regression helps to predict in land use opportunity, and what are the consequences for this?
So ask me to share a book on the well-being.
Yes.
I mean, the well-being, you know, there are a lot of books associated with this. And then, so we do see some, you know, for example, in my research area, we focus on the planning, right? So that's, you know, talk about the building environment and well-being, and also the transportation and well-being. And I know the professor Donggen Wang and Shen Jinghe, you know, they added a book. So that book, you know, we see a lot of studies associated with well-being. So I think that could be a good source for this line of research. And also, I think, you know, there are some review papers. So I think that's also kind of a starting point for the well-being research. But the well-being is so broad, you know, it's hard for me to say, you know, which one is really good. But I would say, you know, the Professor Donggen Wang and Shen Jinghe, I think that's a good one. And in terms of the land use opportunities, you know, I don't feel fully understand this question. And but in general, yes, you know, when we use the generalized linear regression, so in this case, you know, anyway, so if we have a traditional model, we assume there is certain relationship between the two variables. And then we use the data to set, to say, okay, whether or not, you know, the data support this relationship. And then you use the p-value to decide. But if the relationship between x and y is not consistent with that assumption, so that means you reach a wrong conclusion. So that's the reason, you know, the machine learning and then traditional models, they are kind of, in terms of data analysis, they are kind of the two different parts. One is we assume the data follow a model, and then we want to test whether or not that's true. And then the machine learning is we don't assume they have certain relationship. We just want to predict what could be the relationship between these two variables. We don't put any constraints on that connection.
Oh, okay.
So that also kind of, yeah, sorry. That also speak to the kind of, I see one question regarding the advantage and disadvantage of planning machine learning is really, I mean, if you 100% sure the connection is linear, then using linear regression, that's no problem. But if you are not sure, and then once you develop linear regression, you need to check that assumption, whether or not, you know, the residual plot, there's no form, it's random distribution. Otherwise, you know, you are making a wrong conclusion.
Okay, thank you, Professor Cao, and thank you all the participants' questions. Okay, please get back to Dr. Kuo.
Yes, thank you, Professor Cao. Thank you, Dr. Wang. So may I first thank again Professor Cao for the very inspiring talk. We learned a lot, and then so we had lots of great questions from the participants. Before we close this section, I wish to make a very quick promotion of our next seminar. Okay, so let me share my screen. And then, right, yes. Okay, so let me share my screen. Okay, all right. So, yes, so our next speaker would be Professor Pam from University of Birmingham, and then his talk would be on December 7th. Yeah, so we welcome all of you to participate in this in his seminar. Okay, so yeah, before we close this section, so I wish to also on behalf of our department thank Professor Cao for the seminar delivered to our students and of course so all the participants all over the world. And we hope that next year we don't need to meet online, but if you come to Hong Kong, if you come to the region next year, if you're in mainland China, so please also visit us, and then we can have a closer interaction, and then we can learn more from your research, and then we can have more exchange of ideas. Thank you.